All right, Coach Byerly here with the Unit 11 review of exponential functions and sequences. We are going to start off by stating whether each sequence is arithmetic, geometric, or neither one, and then give the common ratio if it is geometric, okay, or the common difference whenever it is arithmetic. Okay, so if it's arithmetic, we're looking for the common difference. If it's geometric, the common ratio. So first of all, let's see what happens when we go from 40 to 43. That would be an increase of 3. Okay, so we're adding 3 from 43 to 46. We add 3. Same thing all the way across. Plus 3. And then 49 to 52 plus 3. So since that is consistent, that would be an arithmetic sequence. Okay, and I'll write A for arithmetic to save some space here. And then the common difference is 3. Okay, now the second one, from 1 to 3, we can look at that as we're adding 2. However, from 3 to 6, that's an addition of 3. So that is not consistent. So it's not arithmetic. Let's check to see about geometric. So to get from 1 to 3, we would multiply by 3. However, from 3 to 6, that is multiplication by 2. So that, again, is not going to be consistent all the way through. That is neither arithmetic or geometric, neither one. Now the last one, we can rule out arithmetic because if we are adding a number consistently, whether it's adding a positive or negative number, our signs would not alternate. So this would have to be multiplication by a negative number to change the sign. So let's see what's happening. From negative 4 to positive 12, we are multiplying by negative 3. So let's see if that continues. 12 to negative 36, multiply by negative 3. Negative 36 to 108, same thing. Multiply by negative 3. And 108 times negative 3 is negative 324. So that would be geometric. Okay, so geometric, and the common ratio that we're multiplying from one number to get to the next is negative 3. Okay, down below this, problems 4 and 5, this says, given the following explicit rules, state the first keyword, first 4 terms. Okay, if you'll notice the problems below 6 and 7, say the next 4 terms. So if we're starting with the first 4 terms, those would be terms 1, 2, 3, and 4, okay, in our sequence. So A subscript n, we'll call it A sub n, equals 65 minus 100 times n. So we're going to follow that rule for the first term. Okay, so if our variable is 4 for the first sequence, we are plugging that in for this n. Okay, and then if I work that out in a calculator, whether that calculator is in your hands or between your ears, that would give me negative 35. Okay, so that's the first term in the sequence. To find the next term, which would be A sub 2, we will go 65 minus 100 times 2. So 65 minus 200 would be negative 135. And we would continue that with A sub 3 and A sub 4, plugging in a 3 for the n on the third term, 4 for the n on the fourth term. And again, this answer key will be either in Canvas or wherever your teacher puts that, but you should have an answer key where you can check these. I will let you finish those last two terms of the sequence. Problem 5, let me help you get this started. So first four terms, again, would be term 1. We will replace this variable, this n, with a 1. So our rule is 8 times 1/4 raised to the n minus 1. Well, if n is 1, 1 minus 1 is 0. Okay, now this is where a lot of people get confused. Anything to the 0 power is not 0. Okay, we're not multiplying by 0. Anything raised to the power of 0 is 1. So this is actually 8 times 1, which would be 8. Okay, it's second term in the sequence. 8 times 1/4 raised to the 2 minus 1. So again, this would be the previous term, the term before this one. So 1/4 to the power of 1 would just be 1/4. 1/4 of 8 is 2. Okay, I'll get us one more, and then you can check the last if you would like on your answer key. So third term would be 8 times 1/4 to the 3 minus 1, or the previous term before 3, which would be 2. 1/4 squared would be 1/16. So this is really 1/16. Okay, so 8 times 1/16 would be 8 divided by 16, which is 1/2. And then again, if you're looking for the first four terms, you would need to find the fourth one as well. And then we would write that, well, where I have a little room, 8, 2, 1/2, and then you would write your fourth term right there. Okay, and again, you can check that after you work that wherever you can find your answer key. My class, we will have that in Canvas in the calendar, just like usual. All right, now problems 6 and 7 say, given the following recursive formulas, find the next four terms. Okay, so the first term they give us in problem 6 is 6. So the next term after 6 would be 7. So A subscript 7 equals, all right, again, n minus 1 just means we're subtracting 1 from the term that we're looking for, okay, which would be the previous term, okay? 7 minus 1 is 6. So that's A sub 6 times, we're multiplying by -3. Okay, if we look back at what the value of A sub 6 was, A subscript 6 equals 2. So that would be 2 times -3, which would give you 6. Okay, if we continue the next four terms, so after 7 comes 8. Term previous to 8, or 8 minus 1, would be 7. Well, if I look back at the 7th term, we had a value of 6. So the 7th term has a value of 6. We are multiplying each term by -3. So we get -18. Okay, this being a geometric sequence is going to continually increase by multiplication of -3. 6 times -3 is -18. So you could go ahead and continue with your pattern here, plugging in 18 for your next one, 18 times -3. Again, it's going to just continue with this pattern. So that's actually going to be -54, okay, for A sub 9. And then again, we're looking for the next four terms. So we have 1, 2, 3. We need to finish with a sub 10, which would be this number, negative 54 times negative 3, which would be 162. All right, so as we write that out, 6, negative 18. Whoops, my fault. That should be positive. We had negative 6 there, so let me go back and correct that. 3 times, or negative 3 times 2 would be negative 6, which got my signs off right there. Okay, negative 6. So let's fix this quickly. I got a little off as we were multiplying this out. So negative 6 times negative 3 is positive 18. Our signs should alternate every time. And then we got fixed back up there. So I'm not sure why I had that sign backwards. But we should have negative 6 for the first term, positive 18 for the second, negative 54, and then positive 162. So again, you have to be careful with your signs. It's easy to make simple mistakes when you get in a hurry, especially if your mind is elsewhere, trying to work and talk and do it all at the same time. So be careful with your signs, be careful with what you're plugging in a calculator, and always double check your answers just to make sure you're not making a simple mistake. Now, this next sequence is going to be arithmetic, because we are adding a specific amount to each term. So as we start with 21st term would be negative 1.4, we would continue with what we did here. So you'd have your negative 1.4. In this case, we are adding 0.6 to every term. So again, your answer key will be in Canvas. You can work that and check that as you finish that problem. Okay, problems 8, 9, 10, 11. We'll do 1 or 2 of these. Given the following exponential function, identify whether the change represents growth or decay, and then determine the percentage rate of increase or decrease. Okay, so if you remember our equation for exponentials, it would be y equals a times b to the x. All right, with our initial starting point, our y-intercept, b is our growth factor, whether it's increasing or decreasing. What we're looking for is this number larger than 1? If so, it is growth, it's increasing. If we multiply by a growth factor of less than 1, it would be decreasing or decay. So 1.74 is obviously larger than 1. This would be growth. And if it is growing, it is increasing. And to get this percentage, okay, we are looking, our formula for growth would be 1 plus the rate for our growth factor. So 1 plus 0.74 is what we actually have here. So we need to be able to change this to a percent. So 0.74, to change to a percent, we would multiply by 100, okay, which is going to move your decimal 2 places to the right and make that 74%. So that would be a 74% increase. Now, problem 10, let's look at that one because that is a number less than 1, which tells me that will be a decrease or decay. So that is going down as we continue through the equation. So first of all, let's figure out what the amount of decrease would be, or the percentage. So when it's decrease, we are subtracting 1 minus the rate. Okay, well in this case, 1 minus r equals 0.97. Okay, so let's just subtract 0.97 from 1, and that should give us r. So if I go 1 minus 0.97, okay, we are going to get 0.03. Okay, and as I change that to a percent, I am multiplying by 100, which again would move my decimal 2 places to the right and leave me with 3%. Okay, skipping ahead to problem 13. In your calculator, and if you have a TI 83 or 84 plus, or maybe a downloaded app which allows you to do the same thing, that'd be very helpful. I think you can do this in Desmos as well. So whatever you've been using for your work throughout this unit, continue to do the same thing. So as I plug this in a calculator, I am going to get in my table -2 would be 1.25, -1 would be 1.5, 0, 2, 1, 3, and 2, 5. Okay, so now that I have my table filled, let's look at what we have. And we'll go ahead and graph this as well. But my y-intercept, I am always looking for where the x value is 0. Okay, so 0, 2. That is going to be my y-intercept. Okay, let's get these other points. So over 1 up 3, over 2 up 5, -1, 1.5, -2, 1.25, and as you continue, it's always good to look at the table to see where it's going to go. But this number right there gives me a good tip. This is not going to go below y = 1, which would actually be the horizontal asymptote. So the asymptote would be y = 1. And again, as you continue that graph, I think if we plugged in a 3 there, that would give us 9. So over 3, up 9. And that's not perfect, but fairly close. Okay, so this graph domain is going to continue forever left, forever right. Domain would be all real numbers. The range, it's never going below that line where the asymptote is, which would be y = 1. Everything on the graph is above that line. So y is going to be greater than the line for our asymptote. And again, you can look here, that number will tell you it's larger than 1, it's growth. But as you look here, as we go up, our numbers get larger. This would be growth. All right, on these problems, it says match the function with its graph. Okay, as you get an idea of these and know what's happening, you can eliminate some, but again, your calculator should be your best friend on this. Plugging in, or in Desmos, plugging in your equation and check out your graph. Okay, as something is larger than 1, we should have growth. Okay, so on the top half of your graph, we know it's going to go that direction. Okay, 4 over 3 would be 1 1/3. That is larger than 1. 2/3 and 0.75 are both less than 1. There would be decay, which is decrease on that. So we can have a general idea of what's happening right here. The other thing, when we looked at our original equations, okay, for exponential functions, y = a times b to the x. A was our starting point, right? Our initial value, our y-intercept. So I know this is going to cross at +3. Okay, so +3, +3. However, this one is decaying as it goes along. This one is growing. So this should be answer choice C. Okay, so Problem 15, answer C. And again, the best bet for you would be to plug this into your calculator and match the graph, noticing where the y-intercept is in the direction of that graph. All right, problem 19, exponential growth and decay. So between 1985 and 2000, the number of people attending State University decreased by 1.4%. Okay, in 1985, there were 17,200 people attending State University. How many people attended in the year 2000? So our equation for exponential growth or decay, which in this case would be decay since we're decreasing, is A, our initial amount, times 1 plus if it's increasing minus if it's decreasing, the rate, and then T would be our exponent representing the time period. Okay, so if I plug this in, our equation is y equals our initial amount, a lot of numbers here, but our initial number of people attending was 17,200. One minus the rate, which if I would, and again, depending on the answer key and what your teacher requests from you, but keeping this simple, since we are subtracting, we're going to subtract the rate, okay, which the rate, we have to change that percent to a decimal. And the simplest way to do that is to divide by 100. Okay, percent means out of 100. So when you divide by 100, that will move that decimal 2 places back, leaving us with 0.014. Okay, so I am subtracting 0.014 from 1. Since it is decay, we're subtracting. And then again, if you simplify this, that's perfectly fine as well. Instead of 1 minus that, we would have 0.986. So if your teacher wants you to leave it as simplified as possible in here and subtract the 0.014 from 1, then you would have 0.986 inside. Now T for our exponent is the number of years. And if we subtract 1985 from 2000, so the year 2000 minus 1985, we will end up with 15 years. So that is my exponent. I'm going to plug this in my calculator, not into y equals. I'm going to just compute what this gives me right here. And when I work that out, I get 13,921 people. Now you may wonder, why do we not round that to a certain decimal point? Okay, we're dealing with people. We're going to consider everybody a whole person. So we do not need decimal places afterwards or any numbers after the decimal. So 13,921 people. Okay, problem 21. During a certain period of time, about 70 northern sea otters had an annual growth rate of 18%. So we are increasing here. It's growing. Okay, how many otters were there after a span of 4 years? So our same formula applies here, with the exception of we're adding, since it is growth. So we're adding the rate. Everything else remains the same. Okay, T for time. Now, on this problem, our initial amount is 70. Okay, that's what we're starting with. So y equals our initial amount times 1 plus the rate. Okay, so I'll just fill this in right here. 1 plus, now our rate, 18%. If I take 18 and divide that by 100, it's going to move my decimal two places, which would leave me 0.18. Okay, so we could put 1 plus 0.18 or simplify that to 1.18. Again, a number larger than 1 represents growth. Now this gives us the number of years. So our time period on this case, in this problem, is going to be 4. And when I plug this into the calculator, we end up getting 135.71. Okay, so again, we're going to look the closest number of otters that would be. The 0.7 would round this up. So we are going to end up with 136 otters. Okay,